We're going to go through some examples just so you guys have some extra stuff before we take the test. Okay. All right, write equation of a line that passes through that point. So this is going to be my x1, y1. And I want it to be parallel to this equation. So if I want it to be parallel to this, I need to know the slope of this line. Now, 2 is what's in front of the x, but 2 is not what your slope is. You can only take the number that's in front of your x to be your slope if you're in y equals mx plus b form. Okay. If I'm in this form, then whatever's in front of my x is my slope. If I'm not in that form, it's not necessarily your slope. So I need to solve this to get y alone. So I subtract the 2x. I get that. Divide by -3, which means I divide everything by -3. So negative over negative is positive 2/3 minus 8/3. Now the only thing I need from here is the slope. That's the slope of the line they want me to be parallel to. And if I'm going to be parallel to it, I need the same slope. So the slope I will use is the 2/3. If I wanted to be perpendicular, I would have to flip my fraction and change the sign. So my perpendicular slope would be -3/2. Okay. But we're going to use the 2/3 because we want parallel. So then I need to use my point slope form, which is this equation. Plug in what I know. So y stays as y. y1 is -1, so that makes it a +1. My slope is 2/3 x minus 6. Distribute the 2/3, which makes this 4. And then if I add the 1 over, I get y equals 2/3 x minus the 1 over makes -5. This is the equation of the line that is parallel to this one and goes through this point. Is y a function of x? The thing we're looking at is, if I solve for y, am I going to be in a situation where my input is going to give me more than one output? So let's take this first one here. If I solve that first one for y, I would subtract the 4x over. So that's 3y squared equals -4x plus 18. I would divide by the 3. So -4/3 x plus 6. And then I would square root. So I have to square root both sides. And remember, anytime we square root, I have to put a plus or minus. Now, with that plus or minus, if I pick an x value, let's say I pick 0. If I put 0 in for x, I'm going to get positive square root of 6 and negative square root of 6. If I'm putting one x value in, I'm getting 2 y values out. And on my graph, when I put in 0, I'm getting positive square root of 6 and negative square root of 6. I'm failing the vertical line test. This is not a function. The other one, if I solve for y, okay, I'm just going to erase this. If I solve the other equation for y, I would get, subtract the 5x over, so -y cubed equals -5x plus 9, divide by -1, and cube root. I get the cube root of 5x minus 9. Now, a cubic root, it's okay to have negatives in there. So you don't need the plus or minus. So if I put a value in, like, let's see, here, let's show it on the graph. I'll actually graph this. So if I graph this math, cubic root of 5x minus 9. Okay, I don't have the plus or minus up front, so I only need to graph this one equation. If I graph it, so let's zoom here. Okay, this is going to pass the vertical line test, because there's nowhere on here where I'm going to have two outputs for one input. Looks kind of close around here. If I'll zoom in there. Okay, we got that. Still looks like it's close, but if we just trace this, my y values, okay, I'm not getting the same y value out. Okay, and I could zoom in more and do the same thing, but it's passing the vertical line test. So this one is a function. Yes, it's a function. All right, finding domain. If you're finding the domain of a radical function, okay, which is a square root function, okay, I can't square root a negative number. I need to find out when this thing is giving me negative numbers. When is that negative? Okay. Well, I graph this one. X squared minus 8x plus 12. Oops, 12. Okay, I'm getting this. Now that's a graph of just the inside part. You notice here, these are negative values. Okay, so that means if I put in these x's, all these x's from here to here, that inside function is going to spit out negative values, and then I'm going to have to square root those negatives, which I can't do. Right before this function becomes negative, it hits 0. Right after it turns back positive, or right before it turns positive again, it hits 0. If I can find those 0 points, I'll know the bounds of my domain. I'm going to find out when this equals 0, when it is crossing those zeros. So when does this thing equal 0? Well, to solve this, I can't move the 12 over and try to do something like that. This is a quadratic, so you can either factor it, or use your quadratic equation. This one will factor. I need numbers that multiply to be 12. Since they're multiplying to be a positive, they're either both positive or both negative. So 12 is 6 and 2. They have to add up to be negative 8. They must both be negative. So that means x is either x minus 6 is 0 or x minus 2 is 0. So that means x is either 6 or 2. That's when it's 0. Okay, so on my graph, okay, here's 2, here's 6. That's where it's crossing. That means right before it crosses at 2, I have positive values, which are good. So I can have anything that's in this area. Anything that's less than or equal to 2. Okay, I say equal to because I can put 2 in. If I put 2 into my equation, I'll get 0, and the square root of 0 is 0. Okay, so another way, if I didn't have the graph, is I know it's crossing 0 at these places. I need to see if this region, okay, are the values over here positive or negative. So I'd plug in something like 0, which is over here. If I put 0 in to my function, I get 12, which is positive. I can square root it. which means these are positive values. I put in something in this middle region between 2 and 6, like 4. 4 squared is 16. 16 minus 32 is negative 16, plus 12 is negative 4. These are negative values. I can't square root negative values. That area is not in my domain. I put something like 7 in, I'm going to get positive again. So my domain here is everything from negative infinity up to 2, and including 2, so it gets bracket, everything from 6 all the way up to positive infinity. Okay, because any value that's in this area gives me negative. So there's a bunch of them. So I'm not going to list, a couple specific points that don't work. I'm going to have a big range of things that don't work. Anything between there, and there's an infinite number of numbers between 2 and 6. The other time that we have domain restriction is when we are dividing by a variable. So I've got a variable in my denominator. I can't divide by 0. I need to find out when this denominator equals 0, because that's what I can't allow. Again, this factors into 4 and 1. That means that x cannot equal negative 4 or negative 1. Just those two numbers. Those are the only two numbers that make this 0. So those are the only two numbers that make me divide by 0. Those are the only two numbers not in my domain. Over here, I set it equal to 0 just to find the points, kind of the boundaries of where it was going to stop being positive and start being negative. Okay? So I'm not looking for the zeros to be, it's okay to have 0 in there. It's not okay to have 0 in here. All right, graphing piecewise. My function follows these 3 rules. Rule number 1. If x is less than negative 3, y is 2. Because remember, f of x is just like a version of y. So all the values that are less than negative 3. So that's everywhere from here over. All of those have a y value of 2. Now, negative 3 does not have a y value of 2, but negative 3.00001 does. So to signify that it's everything leading up to that, I'm going to make it an open circle. Okay, everything less than that has this value of 2 and a little off. Okay, so there's the first part of my graph. I'll keep that green. Let's switch colors here. We'll do blue. Blue is going to include these values. So from negative 3 all the way up to 2. So from negative 3 all the way up to 2. Now 2 I can't actually put in there because it's not equal to 2. But everything leading up to 2 I can put in. So I want to make an open circle there so that you know everything leading up to there is on this graph. So if I put in negative 3, I get 10. If I put in numbers like negative 2, negative 1, 0, 1, 2. Okay, negative 2 is going to get me 5. Negative 1 is 2. Right, yeah. I put in 0, I get 1. I put in 1, I get 2. I put in 2, I get 5 again. But remember, I want an open circle. So everything from here leading up to there works. 2 doesn't work, but everything leading up to it does. This is blue. Last one, red, is for x values that are greater than or equal to 2. Oh, everything equal to 2 and greater. Okay, things like this. If I put in 2, I get 2. So 2, 2. Put in 3, I get 0. Okay, and I get this linear equation that goes like this. That's my piecewise. My piecewise is still a function because it passes the vertical line test, right? Because if I put a vertical line here, it doesn't really touch that point. It only touches this point. If I put a vertical line here, it doesn't really touch the open circle, but it does touch once at the red. Still pass the vertical line test. Still a function, which is why it's important to have, you know, open circles and closed circles. All right, even, odd, or neither. The test for this is to replace all of our x's with negative x's. So here I would put negative x in place of x, a negative x in place of this x, and then simplify. If f of negative x, so when I put the negative in, if I get out what I started with, so if nothing changes, that's even. If I get out the exact opposite of what I started with, that's odd. So in the first case, negative x times negative x is positive x squared, so I get 4x squared. This becomes minus 3x. That's not the same. It's not the exact opposite. This one is neither. This one, if I put in negative x for all the x's, this becomes negative 2x. Negative x times negative x times negative x is negative x cubed. Okay, the negative comes out of there and becomes positive 5x cubed. This is the exact opposite of what I had. So this would be odd. Right. Is this 1-to-1? This one's going to be hard to do the A-B test with. Okay, because if I was to put this equal to this, I'm going to have a rough time trying to get down to A equals B. So I'm going to depend on the horizontal line test. So I'm going to graph this thing. 2x cubed plus 4x squared minus 5. Right there, you see right here, I failed the horizontal line test. I can put a horizontal line here that would touch the graph 1, 2, 3 times. It's not allowed to touch more than once. That means that this is not 1-to-1. No. Alright, this one, however, is going to be 1-to-1. So I have this, and this. I can simplify this. Okay, I would square both sides. I would subtract 5 and divide by 3, and I would get down to where A equals B, which means it is 1-to-1. So it does have an inverse. In order to find the inverse, I'll make that a y, and then I switch the places of my x and y, because inverses switch the inputs to the output. I'm going to switch my input. X is my input. It's going to become my output. My output y is becoming my input. And then I solve for y, because I want a function when I'm done. Functions are y. I'm going to square both sides. That's a y. Subtract 5. I'm going to move over here. And divide by 3. That's my inverse of x. In order to test, to make sure they're inverses, I'm going to move this stuff down. In order to test, I do composition of functions. So I take my original function, take the x out, put my inverse function in its place, and then simplify. So 3's will cancel, then my 5's will cancel, Square roots will cancel. I get just x out. As long as I get just x, they are indeed inverses. So let's use these to do a couple function operations. Actually, I'll do more than what I've got up here. This is f times g of x. Don't get that mixed up with f of g of x. Okay, f of g of x, when it's written with an open circle, that's really the same as this. Okay, but if they just buddy them up like this, that's f of x times g of x. I'm going to take 2x minus 7 times 3x squared plus 5. And I'll distribute first to the first, 6x cubed, this one to that one, and x, this one to that one, minus 21x squared, and this one to that one, minus 35. Okay, so that's what this is. F of g, or g of f of x means take my g function, take out the x, put the f function in for the x, right? Because I had x here, and I've got f of x there. So when I had x here, I need f of x, which is this, in its place. What is that? I've got 3. Okay, don't forget what squared means. Squared means I've got 2 of these things multiplied together. I have 4x squared minus 28x plus 49 plus 5. This whole thing is multiplied by 3. 12x squared minus 84x plus 147 plus 5. You get 12x squared minus 84x plus 152. That's g of f of x. Let's do f plus g of x. That just means I'm going to add the two together. I'm going to take f of x and add it to g of x. 3x squared plus 2x. Combine the like terms. Negative 2. Let's say I do f minus g of x. Take my f function, which was 2x minus 7. Subtract my entire g function. Make sure you're subtracting the whole thing and not just a piece. So I'm going to distribute this minus sign. Negative 3x squared plus 2x minus 12. Switching it there. Alright. How do you find slope? Put it into y equals mx plus b. Here's your slope. Okay, tell y is a function of x. If you see y squared, y4, y6, etc., it is not a function. Okay? Or if x equals a, if I can put a number in, like a, plus f at a equals 2 or more things, then it's not a function. You can only have one output for each input. You find domain of a radical. Radical is this. Set the inside equal to 0. Test your regions. If you get positive in the regions, in the domain, negative in the regions, not in the domain. Okay, find domain of a rational function. Rational is fraction set the denominator equal to 0. Your answers are not in the domain. We sketch piecewise. Make a table. Include values for each piece. Plot the boundaries. These are closed circle. These are open circles. We test for even, odd, or neither. F of negative x equals f of x. Even. F of negative x equals negative f of x. It's odd. We test for 1 to 1. F at a. So f of a equals f of b. Simplify to a equals b. Or horizontal line test. Why do we test for 1 to 1? If they're 1 to 1, then they have an inverse. How do you find the inverse? Switch x and y. Solve for y. Test your inverse. F of f inverse of x should equal x. That should take care of everything.